Good day, everyone, and welcome back to our YouTube sessions. And today we are going to continue to move on from where we left on our previous video. I guess those who have watched our previous video of revision of 2024 May June question paper. So if it's the first time to watch our videos, just make sure that on your way out, you also have time to subscribe to our channel, click the subscription button, notification button, as well as make sure that you also like our videos for more content. So anyways, without wasting much of our time, let us move on into the content for the day. We are going to talk about continue with our revision. So now we are question number 4. And question number 4 on paper 1, which is about functions. So functions, we get g of x, we're given g of x, which is equals to 1 divided by x minus 1 plus 2. So we have the first question. The first question about this function was that we need to be able to write down what are called asymptotes. So now we need to understand how do we write down asymptotes of this function, this hyperbolic function. So asymptotes in this case, our x asymptotes is found by making the denominator to be equal to 0. That is making sure that if x minus 1 is made equal to 0, then what is the value of x? The value of x in this case is going to be x is equal to positive 1. So what's the shortcut that mainly we're used to? We just need to find the value which is the same number as 1, but with a different sign. So our x is going to be equal to positive 1, as well as y value, which is equal to positive 2. These are the equation of the asymptotes. So this was question 4.1. So let's move on to question 4.2 and understand what's happening on question 4.2. On question 4.2, we are still dealing with the same hyperbolic function. The question is now about to sketch for g of x, which is equals to 1 over x minus 1 plus 2. For us to be able to sketch the graph of this function, we need to understand that let us gather up information. We have our asymptotes, x is equals to 1, and y is equals to 2. These are the asymptotes. But you can only sketch the curve if you know x-intercepts and y-intercepts. Let us find x-intercepts and y-intercepts. Let us start with finding the x-intercept. Our x-intercept is going to be found when y becomes 0. So if y becomes 0 here, it means we're going to solve 0 is equal to 1 over x minus 1 plus 2. So solving this one, it means that we're going to bring transpose 2 on the other side. We have negative 2 is equal to 1 over x minus 1. So we cross multiply. In this case, we're going to have negative 2x minus 1 being equals to 1. Divide both sides by negative 2. We have our x minus 1 being equals to 1 over negative 2. So in order to find the x value, take 1 over the other side. It means x finally will be equal to minus half plus 1, which is equal to positive half. So that means our x-intercept is found when x is equal to half. Let us be able to determine what is called the y-intercept. How do we get y-intercept? We get y-intercept when we make x to be equal to 0 plus 2 in this case. So y will be equal to, this is 1 divided by negative 1, it gives us negative 1. So minus 1 plus 2, our answer will be 1. Which means this is now the y-intercept, our x-intercept, and our asymptotes. Let us gather up the information so that we can draw the graph. So putting our x-intercept and our y-intercept, we now know that x-intercept is found when y is equal to 0. This is half exponent 0, our x-intercept. Then we have our y-intercept our y-intercept, we have x0, y is equals to 1. So this is our x-intercept and our y-intercept. Our y-intercept, our x-intercept, and not forgetting our asymptotes. So, since we have gathered all this information now, our asymptotes 1 is to 2. So let us create enough space so that we can be able to make a drawing of this. So to draw our graph, we're going to have our x-axis and our y-axis. We have this equal our origin. So let's put asymptote first. Asymptote is found at x is equals to 1 and y is equals to 2. So if x is equals to 1, this is 1 here. Y is equals to 2, y is equals to 2 here, which means we are going to have the asymptote in this way, asymptote in this way. This is our asymptote. After drawing the asymptote, the next thing is to plot our x-intercept and our y-intercept. Let's plot our x-intercept is found at x is equal to half, which means it's found at this point where it is between 0 and 1. This is half. Then y-intercept is found when y is equal to 1. At this point, y is equal to 1. So that can show us the shape, that the shape of this graph in this case is one in which crosses through this point. This is how we draw our hyperbolic function. This is how we draw our hyperbolic function in this case, but they will be in either quadrants, which means the other side we draw this is going to be, this is our other. So therefore, when you are being awarded marks in an exam condition, you are going to be given marks for the shape. One mark for the shape, another mark for the intercepts, another mark for the asymptotes, which completes also 4 marks for these two, mark for the intercepts and a mark for the shape. So this is how you are going to be awarded marks. So the graph you're supposed to draw is the graph that looks like this. So let's move on to the next question. The next question, it talks about values of x for which g of x is bigger than 0. Now, for us to understand this case, values of x for which g of x is bigger than 0, what we need to understand is that larger than 0, we are focusing above x-intercept. We are focusing above x-intercept. We need to look at how is the graph behaving above the x-intercept. So let us do that, which means at this point, we can see that above x-axis, the graph crosses at x is equal to half. And the graph is going to this side. So therefore, one of our solutions is x is less than half. Or another solution is found, the graph is found over the asymptote. If it's over the asymptote, that means the graph is found on the other side where x is bigger than 1. So x is greater than 1. These are the values. These are the solutions for g of x is bigger than 0. These are the solution for g of x is bigger than 0. The next question is to determine. The next question is determine equation for axis of symmetry for which equation of axis of symmetry. Axis of symmetry with negative gradient. So if you are asked to determine axis of symmetry with a negative gradient, the first thing that you should do is that you need to know that you are supposed to use this standard. Y is equal to minus x plus c. This is the standard that you should use to find. So in this case, we're simply saying we need to find the value of c. How do we get the value of c? To get the value of c, which means for y and for x, let us substitute the asymptotes. We substitute asymptotes x and y at these two positions to find the value C. That's the next step. So where are we getting this? This is the standard when you want axis of symmetry with the negative gradient. If it was axis of symmetry with the positive gradient, that means we would use positive x plus c. That's the only difference. So in this case, let us substitute x and y to find c. Our y is equal to 2 subtract negative 1 plus c. So take negative 1 over there, it means c is going to be equals to positive 3. C will be positive 3. So finally our equation will look like this. Y is equal to negative x plus 3. This is the value that we are looking for. So equation of the axis of symmetry will look like this. Y is equal to negative x plus 3. This is the equation for the axis of symmetry. So question number 4, we're done. We move on to question number 5. So for question number 5, the next question, what we need to understand is that we were dealing with a hyperbolic function. So the next question that we have is a combination of logarithmic function and an exponential function. So our graph that we are given, our graph looks like this. This is the graph that we are given. It crosses here at R. So this is the graph that we are given. It crosses here at Q. This is 0. So something that looks like this, y and x. So given these two combination of an exponential and a logarithmic function, we need to understand that these two, they are usually a reflection of each other, or they are usually inverses of each other. But before we can get to put whatever information that we need to put, let us understand what is the first question. The first question here, we are being asked to determine what are called coordinates of P inverse. So far, we are given that P which is found at this point, and P is 4:2. So 4:2 is the value of P at this point. Now, the question is, what is the inverse of the value of P? The inverse of the value of P. So take note that these graphs, these two are inverse of each other. So there is a reflection of P, which is going to be found at this point. So if that is a reflection of P, the question is, what then are the coordinates of P? So the coordinates of P that were given 4:2, but coordinates of P inverse, which is going to be this, what we are going to have is that we are going to have 2:4. So how do you find then the coordinates of a reflection? Coordinates of a reflection, mainly if it is reflected along the line y is equal to x. As you can see our values here, how you got these values, just understand that you need to swap the two positions. 4:2 is given on our graph. Therefore, the inverse is just a swapping of the two positions. So if it was 4:2, P inverse is 2:4, just like that. As long as it is reflected along y is equal to x. But if it was reflected along y-axis or along x-axis, we'll talk about something different. But for now, just understand, as long as it's reflected along y is equal to x, we exchange positions. That's the value of P inverse. The next question we're being asked to show. We're being asked to show that A is equal to 2. Show that A is equal to 2. But what are we given? What information are we given about this? We have f of x, which is equal to logarithm of x in base A. Logarithm of x in base A. This is what is given. The first question is that we need to show that the value of A is exactly equals to 2. The only way to show this is to find what is called a common point along the curve, such that we substitute x, y, and x in order to find this. Let us find the common point. The common point that we are given is P. P is 4 is to 2. This is the value of P. Now, in order to find the value of A, let's substitute f of x and y and x, which means our y in this case is 2. 2 is equals to logarithm of x, which is 4 in base A. So, the next thing to do is that we need to simplify this value. How do we do that? Take the base, raise to the power of 2, answer is equals to A. This process, we are converting a logarithmic function into an exponential function. This is the only way we can solve an unknown along a logarithmic function. You exchange, you just put your values of y and x, then change from logarithmic function into an exponential function in this way. So a exponent 2, then our a exponent 2 is still the same as 2 exponent 2. Now, exponents are the same. That means bases are also the same. So therefore, a is equals to 2. We have shown that a is equals to 2. Then the next question is that we need to write down, we need to be able to write the inverse of this. So the inverse of this graph, given f of x is equals to logarithm of x in base A, it's no longer base A, our base is 2, which means we put 2 in this position. So since we put 2 in this position, how do we then write the inverse of this? There is a process when you are writing inverses. Step number 1 is to be able to exchange x and y, because this is your y, this is your x. Let us exchange positions. Exchanging positions, it means this y becomes x is equal to logarithm of y in base 2. This is same as y. Y goes there, x comes here. Exchange positions. There's a mark for doing that. The next step is to change from logarithmic function into an exponential function, just the same process we used here. How do we do that? Take our base, which is 2, raised to this power exponent, which is x, answer is equals to y. So therefore, in this case, our inverse is now written as y negative 1 to show that its inverse is equals to 2 exponent x. This is how we write the inverse of this. So our inverse is written y inverse is equal to 2 exponent x. So we move on to the next question. The next question, which is question 5.4. Let us move on to 5.4. So question 5.4, it entails that on the next question, the question is what to find. They say T is a point in the first quadrant. T is a point that is found in the first quadrant. We're not given T in the first quadrant, but they say T is a point along the first quadrant. And where TR is parallel to x-axis. Where TR is parallel to x-axis. So T, in this case, T is in the first quadrant, and TR is parallel to x-axis, which means if we put along a line that is like this, let's assume that this is TR, this is T. So if this is T, let's make our graph to be a bit wide so that we can understand what's happening. We have this, our Cartesian plane. Our Cartesian plane, we have this. This one is R. We also have this. This is, so our R is here. So what we are saying is this. If R goes to make T somewhere along this point, let's say this is our T. So what's next? The question is that calculate area of RTP. RTP. Our P is still on the same point. This is our P. This is our point P. So we make another one. Then we have a triangle that looks like this. So we have a triangle here. So our triangle RTP P is there at this point. So far, what do we know? We know that coordinates of R, we have coordinates of R, which are given as 0 is to 1. So coordinates of R are 0 is to 1. These are coordinates of R. Then, what about coordinates of T? What do we know about T is that this line is parallel to x-axis, which means the same value, the same y value we have here, y value we have here is the same y value for T. So our T, we have a y value which is also equal to 1. But what is going to be the x value? We need to find what is called the x value. How do you find the x value? Remember, we have f of x is equals to logarithm of x in base 2. When y is equal to 1, what is the value of x? That is the value that we're going to get at t. So in this case, y is equal to 1 logarithm of x in base 2. Bring it here, 2 exponent 1 is equal to x. So therefore, x is equal to 2. So that means the value of t is 2 is to 1. Now for us to be able to calculate the, what is it called? To calculate the area of this, we can only get the area of this when we redraw this in a way that makes sense. We're going to have this, we have this, and we can come to this, that this is our T, this is our R, this is our P. So our T, 2 is to 1, our R, 0 is to 1, our P is given, which is 4 is to 2. So now, what is the height? The height at this point, because when you're calculating area of a triangle, we should not forget that area of triangle is always equal to half times base times height. This is the area of a triangle. Our base in this case is RT. So half times base, which is RT, times height. Height is a perpendicular height. So we're talking about perpendicular height, which is in this case, I've reproduced this. So what is this height? Let us focus on y value. Y value of P is 2. Y value of R is 1. So therefore, y value here at this unknown point is T1. So in this case, from 1 until 2, how many units are in between? Which means our height in this case is going to be 1. Because from y is equal to 1 until y is equal to 2 is only 1 unit. This is 1 unit. Now, what is this distance in this case? From R until T. Again, as we move along x values, this is 0. From 0 until x is equal to 2. Which means we're going to have 2 units along this. So 2 units, which means we have our RT being equal to 2. Half times 2 times 1. Our final answer is half of 2, which is equal to 1 unit squared. So the value that we have, half times 2 times 1 is equals to 1 unit squared. So height is 1. In this case, our base is RT. Our base is RT. We have from 0 until this point is 2. From y is equal to 2 to y is equal to 1 is 1 unit, which means half times base times height. Our base, I repeat, is 2. Our height is 1, which means to calculate, we get 1 square unit. That is the value of this. Let's move on to the next question. So that was 5.4. The next question that we're moving on to is question number 6. So question number 6 on your question paper, we move on. In this case now, we have it completely different. We are given f of x, which is the parabola x squared minus 2x minus 3. We also have g of x, which is equal to mx plus c. It's unknown. Our g of x, we don't know the values. It's unknown. So, but information is such that we have this, and this is our quadratic. This is our quadratic, whereby this is E. There's a line that crosses through this point. It crosses through this. So this line crosses through here, crosses through at this point, and this line also goes outside until here. So what we have is that this line is our g of x. This is our f of x. So we have this. Then the first question is that there's t here, which is the turning point. T is the turning point. This is point P. This is going to be point D. Origin. This is point E. So our first question in this case was that we were given turning point T. T was given as 1:-4. T is given, that's the only point which is given in this case. So the first question is that we are supposed to write down the range of f of x. How do we determine the range of a parabola? Determining range of a parabola, we should understand that our focus is on turning point. Here's our turning point. What is the y value for the turning point? Y value for the turning point is -4. So in order to determine the range, we should understand that if the graph is a smile, it means the graph is found above the turning point. The graph is found above the turning point. So what do we do in this case? If it is found above the turning point, which means range is simply y is bigger than or equals to -4. And y is a member of real numbers, just for one mark. You determine the range, and that's it, you're done. So from determining the range, the next question was to find the value of D and the value of E. Let us understand that the value of D and the value of E, these are x-intercepts. These are x-intercepts of the graph. So in this case, we don't need to stress. This is f of x. F of x, when it's equal to 0. So x squared minus 2x minus 3 is meant to be equal to 0. Now, let us solve this. How do we solve a quadratic equation or a parabolic function which is equal to 0? We either use quadratic formula or we can use factorization by inspection. In this case, we can just use inspection method because we have -3. Factors of -3 in this case are -3 times 1. They are also as well the factors that can give us -2 when we find the sum of those two. So what are we going to do? We are going to open two brackets equals to 0, which means x minus 3, x plus 1 is equal to 0. So finally, x is equal to opposite, which is +3 or -1. So these are the x values. X is equal to 3 or x equals to -1. That means coordinates of D. Coordinates of D is on the negative side. It's -1 is to 0. And coordinates of E. Coordinates of E are 3 is to 0. So this is how we determine x-intercepts. This is how we determine x-intercepts. So from determining x-intercepts, which is value of D and the value of E, let us get to the next question. The next question is to find or determine the equation of G. This is our G of x, mx plus c. It's a line. It's a line. So since we are determining the equation of a line, let us see what is the procedure to get to determine equation of a line. Equation of a line. So determine the equation of a line in this case. We write our g of x. Our g of x in this case is mx plus c. So mx plus c. First thing to find, we need to find the value of m. What is the gradient here? So far, what do we know? We know that E is such that 3:0. We also have this point. What does this point represent? This point represents what is called the y-intercept. What is the y-intercept? The y-intercept in this case is a point which is given as y-intercept x is 0, y is -3. These are y-intercept here. So that means we have 2 points. M is the 2 points, 3:0 and 0:3. This point and this point, that's where our line crosses. That means gradient, we shall use the formula y2 minus y1 over x2 minus x1. Now, what is the value of y2? We can choose 0, subtract -3. So 0 subtract -3 divided by 3 subtract 0. Our final answer that we're going to get positive 3 over 3 is going to be equals to 1. So this is the value of gradient. We have the gradient. The next step to do is to substitute any of these two. But before we can substitute, what will you be looking for? We are looking for the y-intercept of this, which is the value of c. But without wasting our time, y-intercept of this line is at this point. What is this point? This point is 0:3. Y here is -3. So what we're going to do is that we're going to rewrite g of x is equal to our m. Our m is 1x. Our y-intercept is at -3. So therefore, we rewrite g of x is equal to x minus 3. So this is the equation of g of x. Equation of g of x is found to be g of x is equal to x minus 3. We move on to the next question. So now we have the equation of g of x. Our next question entails that we need to find, we need to determine, write down the values of x for which g of x minus f of x minus g of x is bigger than 0. F of x subtract g of x is bigger than 0. We need to determine values that satisfy this condition. Values that satisfy that condition. But in this case, before we can determine that, let us understand what does this mean. This means that if we transpose g of x into the other side, we shall have f of x being bigger than g of x. Now, this is a bit complex, but not very complex, because what we should understand is that in this case we are dealing with the values of f of x, which are bigger than values of g of x. Values of g of x. So at this point we want a situation where f of x graph is above the value of g of x. F of x is above g of x. So from this point, we can see f of x is above the graph of g until this point. Now, what is the value here? The value here, value of x is 0. Let us understand f of x where it's above is this region until it gets to this point whereby we have a situation, the graph of g goes on top. So this region is unwanted. I'm going to put an x. An x in this case, we don't want this region. So this is the first region whereby x is less than 0. Less than 0, that means we are coming backwards here. So this side, it satisfies this condition. As we continue on the other side until this point, what is the value of x at this point? The value of x at this point, it is 3:0. So from here, going that side, graph of f is above the graph of g. Why? Because there's greater than. What is the value of x here? X is bigger than 3. So these are the two answers that satisfy this condition that f of x is bigger than g of x. For 2 marks, we have our answer then. So let us move on to the next question. So the next question that we have here is a question that talks about determine maximum vertical distance. Maximum vertical distance between h and g. If h of x is equal to negative, so the condition is that there is a new graph h of x, which is said to be equal to negative of f of x. This is the new graph. There's a new graph which is given as negative of this. Now, let us understand this. This means that h of x is simply a reflection of the old graph f of x along x-axis. So that means our h of x in this case can be rewritten as negative outside x squared minus 2x minus 3, which is going to be minus x squared plus 2x plus 3. This is the graph of h of x. We just need to understand that we substitute our negative inside so that we can change the sign. That graph, if we are to draw the graph looks like this. We have the graph that goes like this. This is the reflection of that, because it's reflected up along this line. So this is the original, which means the reflection for h of x is this graph here. That's the reflection. But what is the question? The question is that maximum distance between h and g. Between h and g. Maximum distance between h and g. So any distance that covers between h and g. How do we find that distance? For us to find that distance, it means we should understand that h of x is above g. It's above the graph of g in this fashion, as we can see. So we subtract the graph of g of x, and then we solve. This is how we solve graphs when we want to find vertical distance between them. So let's repeat that. This is the reflection, vertical distance between this point and the value and any point where the graph of g passes. So we want this vertical distance. It is only found by subtracting h of x minus g of x and then solve. Let us do that. H of x is minus x squared plus 2x plus 3. Subtract what? G of x is our answer. Our g of x, we found it before. Let us find our graph for g of x. G of x was found to be x minus 3. This was g of x. So h of x, subtract g of x. Let us solve this. Minus x squared plus 2x plus 3, subtract x plus 3. Let's continue to simplify. Minus x squared, 2x minus x, we get plus x, 3 plus 3, we get 6. As we get to this point now, the next thing that we should do, we should manipulate the way to solve what is called a turning point. How we find a turning point? Remember, a turning point shows what? Shows a maximum value or a minimum value. So we manipulate the formula for the turning point. Let us do that, which means x is equal to negative b over 2a. Our b is now 1. So negative 1 over 2a, which is 2 times negative 1. So 2 times negative 1, in this case, we're going to get negative cancels, which means our x value is going to be half. Our x value is going to be a half. So what do we do after that? The next thing to do is to substitute this half, this 1 over 2, into this value, into this equation here, that we made, the new equation we made. So, which means the y that we shall find by substituting, subtract negative, this is half squared plus, this is half, plus 6. So let us simplify with the calculator here in order to find the value of this, which means once we do that, we are going to find y 6,25 units. So that means the vertical distance that they ask us to calculate between this and this is 6,25 units. Let's go through the process again. The process, we said h of x must be made according to this, because this is the reflection. So next step, introduce negative inside f of x, we get this. Because we want a vertical distance, then h of x is above g of x, subtract g of x in this case. Subtracting them and solving them or simplifying, we get a new equation, which is this, minus x squared plus x plus 6. After we get that, then I said the word maximum, we should manipulate the process of finding a turning point, because it also gives us what? A maximum value. So therefore we go through the process, or there's another process, another step whereby you can use dy over dx, which is going to give you the same answer though. So you go through the process, find using the formula negative b over 2a. Our b is this, our a is negative 1. Simplify, we get 1 over 2. After getting 1 over 2, substitute into this. Substituting into this equation, it gives us 6,25 units. So that's how we find the maximum distance. The next question. We move on to the next question. The next question is such that being asked to find, we are given a new graph. A new graph, we are given a new graph, which they say that this graph now is kx. Kx, they say kx is equal to g of x minus n. G of x minus n, that is kx. So since we have g of x minus n, what do we need to do? What we need to do in this case is to understand that for us to find the value of n, the question is find the value of n if k is to be a tangent. If kx, this graph, is to be a tangent to what? To f, to this graph. If it's to be a tangent, we should find the value of n. So the first step to do is to understand that our kx can be rewritten. G of x is x minus 3. G of x is x minus 3. Since we have x minus 3 in this case, subtract n. That means kx is equal to x minus 3 minus n. But this does not change the fact that this kx is still in this format, mx plus c, whereby coefficient of this 1 is also m. Our c is both of them. So therefore, we are going to manipulate the fact that we already know the gradient, which is m, in this case is invisible 1. So 1, which is the coefficient of x, in this case is the m. That is our gradient. But how do we get this m? M is found by dy over dx. What is dy over dx in this case? We are going to use dy over dx for the f of x. The derivative of this is always the same as gradient. We shall discover that even during calculus, when we shall approach the calculus question, if you want gradient of a curve at any point, it's always the same as derivative, dy over dx. So let us determine that we are deriving this. Bring down 2 is going to be 2x minus 2. This is the gradient. So since we have the gradient, what are we going to do next? We make it equal to 1, so that we find x. Because I said this is the process to find the gradient, 2x minus 2, which is this dy over dx. But already the gradient, we know that this is the coefficient of x. The coefficient of x is 1. So therefore, 2x minus 2 is equal to 1. Take 2 over there. 2x is equal to 3. So therefore, x is found to be 3 over 2. So x value at this point is 3 over 2. X value it is 3 over 2. So once we find x value, let us substitute the x value into the original f of x so that we know what is called the y value. Let us do that. So y in this case is equal to x. X is 3 over 2 squared minus 2, 3 over 2 minus 3. Let us simplify this with a calculator. It is going to give us the value that we want. It is going to give us the value of y, which is negative 15 divided by 4. So we found that y value is this, x value is this. This equation, the new one, it passes through the same point, which is, in this case, x is equal to 3 over 2, y is equal to minus 15 over 4. This equation, kx, is going to pass through this point. Since it's passing through this point, what do? Let us create space. Creating space in this case, it means we are going to substitute the values into that kx. Let us substitute into that kx. We have our kx being equals to x minus 3 subtract n. So x minus 3 subtract n, it means that this is y, which is negative 15 over 4. X, it is 3 over 2 minus 3 minus n. We are solving for n. So take this one over here. It means negative 15 over 4 plus 3 over 2 plus n. Let us subtract here. This is positive. It becomes negative. Negative becomes positive. Is equals to the value of negative n. So let us simplify, in this case with the calculator. So simplifying this one is going to give us the value of n, of negative n, the value of negative n being equals to negative n being equals to negative 9 over 4. Negative and negative, therefore n is equal to 9 over 4. So we now have the value of n. That means n should be 9 over 4 for this kx to become what is called a tangent to this. So this is almost the same process that we use when we want to find equation of a tangent, be it equation of a tangent on a hyperbola, on a parabola, on a cubic function. We found them in the same way. So let us move on to the next question. We are done with functions. So now we move on to the next question, which is a question on finance. So we are approaching the finance question. Let us see what is the question on our finance question. So the next question on our finance question, we are given information about this guy. I guess those with question papers, all of you, I guess you can see that there's a guy, his name is Tabo. Tabo bought a phone. A phone, the price was 13,000. Tabo bought a phone that was worth 13,000. And then what's next? The value of this phone is depreciated. So this is a question about depreciation. This was the original price. The phone depreciated, which means price now, after depreciation, the price now is 8337.75. This is the new price. His phone was worth 13,000 when he purchased it. The phone depreciated to 8,337.75 cents. So He used this phone for 6 years. He used the phone for 6 years. The method of depreciation, was reducing balance. This was the method, reducing balance method. So, what is the question? Our question in this case is that we need to calculate the annual rate of depreciation, in this case, which is our I, rate of depreciation. So, to get that, we should understand that our formula is A is equal to P, 1 minus I exponent N. This is the formula in this case. Our A is 8337,75 is equal to P, which is 13,000. 1 minus I exponent 6. So this is the equation. What we're going to do next, divide both sides by 13,000. Now we're solving. So this is substitution of the information here. So all the question about finance, make sure that number one, gather up information of what you're given. This is what is given, and what is unknown is I. So we are also told this is the method. If this is the method, the reducing balance method, it entails that you are going to solve this using the formula A is equal to P 1 minus I exponent N. So we substitute A. A is not always the bigger value, just to correct some sentiments. Is that A is not always the value which is large, but A is the value of the, if it is depreciation, is the value of the asset after it is depreciated. So the next thing to do is that let's divide both sides by 13,000. 8337,75 divided by 13,000 is equal to 1 minus I exponent 6. Now to remove exponent from this side, it means I'm going to have the sixth root of 8337,75 divided by 13,000 is equals to 1 minus I. It is equals to 1 subtract I. So since it is equal to 1 subtract I, the next thing to do is that we need I. Take I here, take this unit over there. So that this I is negative, it comes here, becomes positive. This unit, sixth root, goes over being subtracted from 1. 1 minus sixth root of 8337,75 divided by 13,000. Now we need to punch our calculator in order to find what is going to be the value of that. So in this case, our value of I is going to be 0.0714. But as a percentage, we should multiply by 100. That means our I is 7.14%. So rate of depreciation is now found to be 7.14%. So this becomes the rate of depreciation for this question. We move on to the next question. Our next question on finance. So our next question on finance is a question on future value. A question on future value. We have two people. Two people in this case. One, his name is Eric. Another one, the name is Tandy. So we have two people here. These people, they want to buy a phone. But okay, these people, they want to go on holiday, They want to go on a holiday. They both want to have 80,000. They both want to have 80,000 after a certain period of time. So in this case, for Eric, let's start with Tandy. For Tandy, they said she decides that she will start saving at the end of January. She will make 36 monthly deposits, which means N is 36 monthly deposits for Tandy. She's going to have 36 payments in an account. And interest for this one is going to be 8.6% for Tandy. And then compounded monthly, which means we shall divide by 12. And at the same time, this is the only information that we are given, that after a certain period of time, we don't know how much she's paying every month, but what we know is that at the end of a certain period, Tandy must have 8,000. So we want to know how much is Tandy going to be paid every month. For us to be able to do that, we need to make a calculation and understand how much is Tandy going to be paid every month. So we shall use the formula for future value is equal to x1 plus I exponent n minus 1 divided by I. So in future, Tandy wants to have 80,000. 80,000 is equal to x. We don't know x. So 1 plus I, our I is 8.6 over 12 compounded monthly for 36 months minus 1 divided by 8.6% divided by 12. Divided by 12. So let us write it properly so that we can all view exactly. So let's rewrite it on the other side. Let us hold this one for Eric. So we're saying she must have 80,000, which is equal to x. We don't know. What we know is that interest is 8.6% over 12 minus 1 divided by 8.6% divided by 12. So this is substitution of this formula. This is f equals to x. X we don't know. This is the bracket, our interest, subtract this. Now, let us solve to get to know how much is she going to be paying in the account every month. Cross multiply 80,000, 8.6% over 12. We divide by this unit, which is 1 plus 8.6% over 12 exponent for 36 months. For 36 months, subtract 1 in this case is equal to the value of x, which is the monthly payment. Now let us press our calculator and let's see what answer are we going to get. So our x value in this case is going to be equals to, our x value is equal to 1,955.78, which means this Tandy every month she will be paying 1,955.78 every month. But in order to understand what the question is asking us to do, we need to know that we are being tasked to find what is the difference between their total deposits. So the difference between the total deposits is such that just like the amount they were depositing every month, before we put into account interest, how much were they depositing for their periods that are different? So for Tandy, we understand that she did this for 36 months. Let us multiply by 36. Multiplying by 36, this is going to give us 70,408.08. This is what Tandy is going to deposit after 36 months. So after 36 months, Tandy has deposited 70,408 rands and 8 cents. Now let us see how much is Eric depositing every month. So Eric is given. They told us that Eric is depositing 1,402.31. This is what we are told that Eric is depositing every month. But for the period he is depositing this amount, how many months for Eric? They say he's doing this for 48 months. Let us multiply 1,402.31 for Eric. It gives us 67,310.88. This is how much Eric has deposited. So finally, to answer the question was, what was the difference after they are done depositing during their periods? Let's take this 70,408.08. Let us subtract 67,310.88. Let's see how much is the difference. The difference in this case is found to be 3,097.20. So this means that the difference between their deposits is 3,097 rand and 20 cents. So this is how much is the difference between their deposits between these two guys. So thank you so much for watching our videos, and our series number 2, it ends here. So just watch out for the next series, which is also coming very soon, which completes the whole question paper 1. Thank you so much for watching, and those who joined us today, don't forget to subscribe to our channel, don't forget to share, don't forget to invite others so that they can also enjoy and also be educated through our videos. Thank you so much.